section of the ArcSight Smart Connector and Flex Connector Framework tutorials. In this tutorial I'm going to show you how to create a flex connector for events and log files that don't necessarily come through as already tokenized or key token pairs or something like that. This particular example is going to be a little bit more complicated in that we're having to deal with messages that aren't necessarily the same from message to message, in which case we have to consider the notion of using what we call subparsers to define and tokenize various sections of different events. So what's a good example of an event type that would give us these types of messages? And I think a really great example is a unified threat management or a next generation firewall device. So if we take a look at some firewall logs that I've captured, first thing you're going to notice is that obviously the message length differs from line to line. It's really quite coincidental that it goes from short to long to short to long, but what's going on here is that we've got multiple different types of messages that a single flex connector, or I should say a single parser within a flex connector, is not going to be able to deal with, particularly if we want to tokenize heavily the actual event itself. Now, if we're happy just dropping most of the information into a single message, well then we don't need to worry about this sub-messaging piece. However, we want to gather all the information that we possibly can, tokenize it, and have it push into our log management or our SIEM or correlation layer for further analysis. So, what can we see about this message, or these messages that we need to actually consider for tokenizing? And you'll notice that if we go from left to right in a message, not only are the messages different in size, but there's some pieces to it that are common, such as this seemingly an IP address at the front. There always seems to be this token of FW or a VPN or even an SSL. Then we've got a timestamp or date timestamp, some sort of an attacker address with the source port, and then the destination port with the target address. That would make sense. It's obviously some sort of a web server. The application protocol that's being used, in which case if we look through here, it's always TCP, but there's possibly a UDP somewhere in the log file. And then an action, which this is nice. This has got an equal sign for us, so that makes it a little bit easier. We may make use of that. And then a extra piece which is called the message. Now the message in this case is just the rule that's being fired. And some people like to actually get that information, which are their most popular rules on their IPS or firewall and so forth that's actually triggering and firing. So this is actually useful information, so we better make sure that we grab that. But if we go down to another message, the message is a lot longer and we've got some totally different information embedded in there. You'll notice on the first line we had rule 25, that's great, we'll capture that. However, we've got rule number 4 here on the second line, but we've also got the notion of a username. Well, this first message has no concept of a username in it. So that's interesting. We're going to have to consider parsing these two different messages in a different manner. In other words, we're going to have to use sub-messages to achieve this. So what's the piece that we can actually sub-message on? How can we identify different types of messages and the sub-parser that needs to be utilized to actually parse that message? And if we scroll from left to right, we'll notice obviously it's really rather obvious that there's a firewall module, a VPN module, and even an SSL module down here. Great. Now if we keep scrolling across to the right, we notice that the differences for the rest of the message really do come down to which module we're dealing with, whether it's SSL, firewall, or VPN. So this is probably a pretty good trigger point. And we'll be able to test this with our complete log file to see whether our thoughts and our theory actually hold true. So if we keep scrolling through this file, we're pretty sure that this is the place that we can start. So how do we actually begin building out this flex connector. I think the easiest way to build a flex connector of this kind is through the Smart Connector framework and utilizing a module within the Smart Connector framework called the regex tool. And you saw in previous sections where I was using the Flex Agent Wizard, which is another tool that you can use to basically tokenize effectively CSV files. Well, obviously in this case, this is not a CSV file. There's a little bit more to it than that. So if we run ArcSight, and if we're running a Smart Connector, obviously we'd just run ArcSight agents just as we always would. However, in this case, what we're going to run is regex instead. So it's going to start the particular module up. And what we're going to do is expand this application. This is the regex tool that comes with the ArcSight Smart Connector framework, and it's very, very effective in building out not only basic smart, flex connectors, but also the more complex types as well, particularly when we're obviously dealing with regex. So where do we begin? Because there's obviously a lot of buttons and so forth on this page. Where do we begin? And there's a very real set process and order of events in which to build out your flex connector in this tool. And after a couple of practice runs, you get the hang of it. It actually becomes very, very easy and a very effective tool to use. So first thing we want to do is create a new Flex Agent regex file. So we basically want to create a new configuration file, because all this tool is doing is building a configuration file. If we were really, really good, we could just write it from scratch ourselves in VI or gedit or Notepad, whatever your flavor is. But this tool allows us to interactively build that regex file out for us. So let's start with a new one. Now, Flex Connector agents are kept under the connector current user agent flex agent directory. That's the same, pretty much the same for any flex connector. And we simply give it a name. We don't need to worry about giving it .sdkr file reader .properties and so forth. The program will put that on for us. So let's just call it firewall regex. That's the name of our configuration file. This is the file that the tool is now going to work against. Right, now the next thing we need to do is give the program our events. So we'll load a log file. In my case, I've got mine down here in opt ArcSight connectors, firewall regex.log. This is just this file here that we were looking at before, so nothing special going on. Open that file. Now, what's happening here is each event from that file is being loaded into this message bar here. And as we scroll through the events themselves, you'll see they're highlighted in yellow. Why are they highlighted in yellow? They're highlighted in yellow because the regex that's passing them is everything. Just give me everything. We know that dot or period is a symbol, is regex symbol for anything, and star is basically more than one or more than zero. So that's effectively our token. So if we were to take this and just leave it as is, and then save this and use this as a flex connector, we would end up with all of that information in a single event field in ArcSight, in Logger, whatever it may be. Event.name is going to map to message, and you can see the value here. So it's effectively the entire message. That's not particularly useful for us. There's no real point in continuing on and utilizing this. We need to start tokenizing this file. Now what you typically do is, well in this case anyway, because we've got a sub-message token ID right up here at the front, we want to keep that and we want to tokenize everything that we possibly can beyond that point. And then after that commonality comes our sub-messages. but this part here, this is the piece that's going to give us that trigger point for the sub messages and the patterns themselves. So let's start by we can go through and start to create this manually if we want to, but there's probably not much point. We can let the machine do it for us. So let's go back to the first event and hit the generate button. We hit generate and we get a lovely long-winded piece of regex. Now it's not going to take us too long to work out that that's not particularly optimized. We can do better than that, and we can further tokenize with sub-messages. So let's look at that later on. But you'll see further down here under common elements, we've got a bunch of tokens now. Fantastic. This is the first part of being able to get something meaningful out of the event. So you'll see that the second column label gives default names. The first thing you want to do is start giving these things meaningful names. So I typically start with, so this is the date stamp. So obviously the first one, the first token, if I just break that up a little bit, 2.2.2.1, right? This is this first token here. Now the reason you saw that turn to blue is because it can't parse after that. If I take that white space out, I can suddenly parse again. So that's our first token. So this is obviously an IP address. Great. We'll leave that for now. Token number 2 is some sort of a date stamp. It looks like to me. So I'll we'll call it date time. We then continue on here after the date stamp, and we can see a full colon here. So that's probably where the actual port number is. And yes, that's where the port number is. Great. So we can say this is perhaps our attacker address. This is our attacker port, attack port, or source port is probably a better word for it. This guy is our target IP, and this is our target port. Now, when we actually, as we perform operations in this program, it's really important to save it as we go. Not so much from a stability perspective, but the save button actually acts as a synchronization button between what's going on up here in the top half of the GUI and what is actually being written to the file down here. So in the very bottom part of this page is actually our configuration file, our regex configuration file, and that's what's being worked upon by this top part of the GUI. So it's really good practice to save as we go a lot. And as you saw, when I hit save, then it started to do things, and of course it's written out all these new token names that I've come up with. It's changed them from $1, $2 to the more meaningful names that I've given it. So that's our first part. Now, what we typically do is once we've finished with the common part, we want to capture the rest of the message. So our dot star. Okay, so what have we got here? What's common? What's common is basically up to the point. If I go to the next message, I've pretty much got a common point up to the target port. Now, of course, if we go to the this application protocol piece, that could be UDP, it could be something else, so that may not be common. So we'll leave that, and we'll assume our commonality ends here at the target port. And you'll see that my common regex is failing miserably, except when it's exactly the same message, effectively. So what can we do here? Let's now start to tokenize this up, and you'll see as I'm backspacing and deleting this regex, the highlighted yellow starts disappearing as well, so I can track where I am in the message. It makes it very easy to visualize. Otherwise it's incredibly easy to get lost. So we've come up to this point. Now after this, that's the part I just want to grab in its entirety. Now once I've done that, this part is not synchronized, so let's just save right now. And you'll see that the values actually come in there. So in other words, it's synchronized the file for me. Great. So now I can say something like rest of message. This is just a placeholder because that's eventually going to be tokenized up anyway. I'll save that again. So now this particular regex is failing only when we get to this part here, this module piece, FW. Right, so that's obviously an important piece. So we want to tokenize that as well. That becomes one of our tokens that we're interested in. So let's change that. Instead of just leaving it as static letters, let's make it something more meaningful and a token, so to speak. Great, so that's all turned yellow again. So I can now save that again, and suddenly I've got myself a new token. And you'll see also, because I've done it out of order, it's gone and messed up my label names. So I might want to fix that up. However, for the purpose of the exercise, we'll keep pushing on. So typically you would build your regex from left to right, but I've left that out. You'll see if I go back here, it's a little bit. So I'm going to call that module. I'm going to call that date. Attacker IP. Attack port. Target IP, target port, rest of message. Right, let's save that. Right, now we've tokenized it more to how we want it to be. That's a much better way of doing it, because now, and I quite deliberately messed that up so I could show you what happens now, is that suddenly we're back to yellow all the way through the message, and this notion of this module is now tokenized as well. So we're grabbing that separately as a token, a message token. So this is good. So now I'll go back to the start. So as we can see, the only reason why we're getting yellow highlight, in other words, successful regex parsing throughout all the messages, is because we've got this dot star at the end. So all the uncommon stuff is just being grabbed, and it's making no attempt to tokenize it. So now we want to go through and actually start tokenizing that as well. And we do that with, of course, the sub messages. So what is our sub message ID? What identifies, which token identifies the fact that we are going to deal with a sub parser or a sub message? In my case, it's module. So it's going to be FW, SSL, or VPN, module. And what's the sub message? What's the part of the message that we need to parse separately? What is the part of the message that's unique to this particular sub message ID? And in our case, it's this dot star at the end. We want to tokenize that separately to any other type of message. So the sub message itself is, of course, rest of message. And as soon as I do that, it's suddenly pulled out that piece of the event that is unique, or part of that dot star. So that's really handy. So when we see FW, it's then going to start to try and tokenize this. Now at the moment, that's pretty poor regex. We know that there's the opportunity for it to, in a firewall, it could be action, it could be drop, deny, block, it could be anything. Obviously rule 25 is not going to be the rule that fires every time, so this obviously needs to be tokenized. And of course we've got more than just TCP available to us. It might be ICMP, UDP, etc. So let's start to tokenize that. Or for the sake of creating the sub message, we could actually hit the create button. What this is going to do, this is going to create our first sub message for the FW sub message ID, because we can have multiple sub messages for that sub message ID, but not in this case. Let's hit the create button. Now when I hit the create button, I've suddenly got myself a pattern, our initial pattern. I can have multiple patterns per sub message, as I just said. And if you look down here, the sub message ID, as we've been saying, is FW. I've only got one pattern I'm dealing with. Lucky me. Great, makes it easy. And then the actual pattern .regex, the actual regex, is this, which is up here. Not particularly well done. We could do better than that. So we've got our first sub message. Let's just save that, synchronize everything up, and let's go through. And again, these tutorials assume you know a little bit about regex. It assumes that you're not a completely new to regex itself. So what you'll be familiar with what I'm doing here. I'm basically saying this part here could be TCP or UDP as a value within the bracket, within the parentheses. Not really interested in action, but I am interested in drop. So I'm going to tokenize that, and I know that could also be deny, it could be block, it could be accept, it could be allow. But in the real world, I would obviously go through my log file and understand which values that could actually take. I'm not particularly interested in the word message. I'll let that go. But I am interested in capturing the rule and the number of the rule. So I'm going to go ahead and do that. And now I've captured rule and then whatever the number of the rule is after that. So I'll save that as I go, and you'll see that message, or that regex pattern down the bottom here gets updated. Fantastic. So now, if I start scrolling through, obviously I'm all yellow here for this, but I'm yellow for this, but you'll see that this sm.pattern has turned red, or the sub message pattern has turned red. What that means is, hey, I don't have a sub message that can parse this particular event. So in other words, I've probably got some more sub messages to deal with, and that's fine. So let's go ahead and create our second one. Our second one's easy to spot because it's dealing with, instead of FW, it's dealing with VPN. So all we need to do here now is the program has already said, hey, I know your sub message token ID is VPN. I know rest of message is the actual sub message itself, and of course this differs greatly to what we saw in the firewall message, so that's good. So now I can go ahead and, like I did before for firewall, just hit create and create a pattern for it. And bang, there we go, there's our pattern. It's been created down here in our actual configuration file, and you can see the regex is starting to be built out here. Right, again, synchronize it up and save it. Again, just go ahead and tokenize it a little bit more. Block, deny, whatever it may be. This is an interesting one here, in that we might be interested in this text that occurs here up to the comma. And you'll see, bang, as soon as I do that, it goes back to yellow. So I know I'm parsing it correctly. So this is actually going to be a token all the way up to the first comma that it sees. Great. That means I'm capturing encryption failed in a single token. So we might see other events like encryption succeeded or authentication succeeded or something like that. So that will be a valid token, and we'll work more on that later. Here's the one that we're really interested in: username. Fantastic. We really do want the username. We are pretty confident it's always going to be a single user name with no spaces. So we can put in /w+, so we know it's always going to be one or more non-white space characters. And then after that, again, like we did with firewall, we can get rid of and just tokenize that rule as well. So Now, obviously, we're also making some assumptions here that the number of white spaces are always going to be consistent or constant as well. Be careful of that. That's sometimes not always the case. If you get yourself a second space in here, for example, that suddenly breaks our tokenization. You may, if you want to be really strict in your regex, do something like a /s+, which means one or more white space characters. So if I now have multiple spaces in my message, that's okay. It's still going to tokenize for me, whether I've got many but not none. Great. I'll save that. That's my next sub message done. Fantastic. We haven't actually come through here to map the sub message elements yet, but we'll come to that very shortly. So if I go back to message 1, great, that is parsed by our first sub message ID. VPN, again, parsed by a sub message ID. Firewall, great, yep, that's done as well, no problem. But then suddenly again we've got sm.pattern turning red. Sorry, I don't know how to deal with the fact that I've got an SSL in here anymore. Right, sounds like we've got another sub message to create, so let's do that. Again, hit the create button, and like we've done before, let's tokenize it up a little bit. Message equals accept, deny, might be allow, might be block, might be drop, message, SSL VPN accelerator module 2, we'll tokenize that. We might want to take out the 2, we might not, just depends. In this case we're just going to grab the whole lot. Get rid of all that. Suddenly we turn yellow again, and then we token up the rule again. May or may not be 101% accurate, but we'll soon find out when we start scrolling through our test data or our test log file again. And as we scroll through, you'll see that I'm getting all yellows. I'm not getting any sm.pattern being red. So in other words, for every event that's coming through, I'm able to parse it, if not by a sub message itself. This is good. So I've gone through many events. As you can see, I'm not having any real problems there, so that's good. So it looks like I've got myself a working parser. So what we want to do now is here start mapping our sub message elements. So let's start parsing this, mapping the sub message elements. So protocol generally in Ceph is going to be called, as I click and drag it over, it's generally going to be application protocol. Oops. I'll reload the parser. If you get a message like that, you've tried to cast one type to another and it hasn't worked, you've hit the wrong button, you've tried to get push an IP address to a string or vice versa, and you get a nasty message like that, you simply reload parser, and that's going to take you from where you left off, where you last saved. So this is why I say make sure that you save very often. It's a good practice. So let's try that again. In here, $1's already done for me, so let's go application protocol. Scroll down. Obviously these are all the Ceph fields that are available to us, so there's a lot there. Now drop, deny, allow and so forth is generally device action in Ceph. I say that generally. Now something like rule 25, that might go in a device custom string. I don't know where that should go right now. We can always sort that out later, but let's just put it in a device custom string for now. So let's make it device custom string 3, for example. Great. We'll go to the next sub message. VPN. This again is going to be application protocol. This is going to be device action. Whoops. This is probably going to be something like message or maybe even name, but we'll put it in as message for now. As you can see, there's a lot of fields available. Now, J. Smith, more than likely target user name. Because we've had a failed login attempt or a failed encryption, the target itself is target username is probably what we're looking at here. Destination username, I should say, because we haven't got it into ESM yet. So let's just scroll up, destination username. As we did with the last module, that's going to go in rule number custom string 3. Right, again for the VPN module, we've now tokenized that and mapped the fields correctly. So as you can see, if I scroll back up here, we're starting to really map these out correctly. So these tokens, as you can see here, are then being mapped under here, pattern 0.fields, and they're the fields that we're mapping those tokens above to. So it's all starting to come together now. Firewall, nope, we've done that. SSL, great, let's map this one. TCP, again, application protocol. As you can probably imagine, this is going to give us useful information like, you know, based on policy or rule 5, what's the most popular protocol hitting this particular device, that sort of thing. You know, do I see spikes and so forth. So already, when we take the time to tokenize things properly, we get ourselves a lot more possible use cases and information to draw out of that data. Device action again. This is going to be the message. I think I made it. And this one here is just custom string 3. May or may not be useful, but we'll grab it anyway. I typically grab as much as I possibly can. You can always delete it later on. Save that. And now, to test, we can simply scroll through the file. We can see that things are being mapped correctly. Now, in the real world, you wouldn't settle for just 60 event messages. That's a pretty small subset of data. You probably want to grab several hundred or maybe even 1,000. And it's no big deal to simply just scroll through it like this very, very quickly. As soon as you don't see yellow, as soon as you see blue or grey, you know you've got a problem. Or sm.pattern being red. So in this case, I've been through every single message and I'm all yellow. So I'm pretty good to go with that. That is actually my Flex connector now done. So once we've finished that, now that we've finished that, the next part will actually go through putting the Flex connector into the connector framework and actually firing it up and then sending the events into ESM. So that's in our next session. Thank you very much for watching.